helium nuclei is 4.00260 U. So calculate the binding energy per nucleon of the helium-42, 3 marks. So as we know, helium-42, we have the nucleon number 4 and also proton number 2. So we can calculate the neutron number by 4 minus 2, the nucleon number minus the proton number. So we have the value of 2 here. And in order to calculate the mass defect, we have the formula ZnP plus NMN minus the mass of the nucleus given. So just substitute all the value given, don't round off any value, and finally we get our delta M in atomic mass unit. In order to calculate the binding energy per nucleon, we have the binding energy is delta M times 931.5 MeV. So if our delta M is in kg, we need to use this formula instead. EB is delta mc square and our unit of the EB is in joule. So for this one, we have the unit of binding energy in EB and we have 1 mark here. And next we substitute the value of delta M. We have another 1 mark for the substitution. And lastly, we have the binding energy per nucleon value 6.82 MeV per nucleon, 1 mark. Next, for question number 10b, a thorium isotope decays into palladium. The half-life of the thorium is 24 days. If the initial activity of the thorium is 10 microcurie, calculate the activity after 72 days. So for the final activity value, we have this formula. A equal to N naught exponential negative lambda T. And before we calculate the final activity, we need to have the value of decay constant lambda. So in order to calculate lambda, we have the formula of lambda equal to ln 2 over T half. This is the value of half-life. So we take the value of half-life in 24 days. So our lambda will be in the unit of per day, or we can convert it into per second. 1 mark for the value of substitution and also answer. And next, we substitute all the values given. So please remark for the value of lambda and T must be in the same type of unit. Let's say our lambda in per day, our time must be in day. So this is our final answer. You can have it in curie or becquerel. So becquerel is actually the SI unit for the activity. So 1 becquerel meaning 1 decay per second. Next, we have question B2. B2 is calculate the time it takes for 90% of the thorium to become the palladium. So meaning the 90% is the decay amount, so we have 10% left. So for the 10% left amount, which is our final value of N, so we have N final is 100% minus the decay one, 90%, we have 10% left. So 10% over 100% is 0.1 N naught. For the N final equal to 0.1 N naught. And our value of lambda and T must be in the same value, same unit. So if our lambda in per day, our time is 79.4 days. So we have 1 mark for the substitution and 1 mark for the answer with correct unit. Thanks for watching.